Alright, so this next video dives a little bit more into this term called the discriminant. Kids a lot of times are like, I hear that word all the time, but I still don't get what is the discriminant. So your discriminant is b squared minus 4ac. Remember, that is the term that lives underneath our radical sign. But the discriminant is this value before you take the square root of a value. Alright, so make sure you understand this is before you take the square root. Alright, the discriminant tells us the number and nature of the function solution. So here we go. If b squared minus 4ac is greater than 0, so what that means here is that it's positive. That means the equation has two real solutions, and its graph is going to look like where the quadratic crosses the graph twice. Now keep in mind, if it's a perfect square, then that means that they are rational, and if it's not a perfect square, then that means that we have an irrational value. But it doesn't matter, it's still two answers. Okay, if I have b squared minus 4ac is equal to 0, so if b squared minus 4ac is equal to 0, that means that I only are going to have one solution, because I cannot plus or minus to get two different values, because plus or minus 0 is the same value. So the equation has one real solution, and the graph is going to look like this, where it sits right on the axis. If it's negative, boop, anytime it just touches the axis just that one time. If my b squared minus 4ac is less than 0, that means it is a negative value. So when we talk about this, there's two different considerations. You can say that there are no real solutions, because what this means is I am taking the square root of a negative value. And I can have then two imaginary, and remember we also call them complex. You're like, yes, it's very complex solutions. So when we're talking about this kind of a scenario, we're going to have my graph either floating or sinking, meaning it never crosses the axis. So we can say here, never crosses the x-axis. And here we say it touches my x-axis. And here we can say that it crosses my x-axis. So paying attention to the value of b squared minus 4ac tells me an awful lot about my solutions. So it's kind of cool that I can see from here what it is that the behavior of the graph is going to be. All right, so in this next part, we're just finding the discriminant. So when we do this, we're going to say, okay, a is equal to 1, b is equal to negative 6, and c is equal to 10. A, b, and c. So if I know the discriminant is b squared minus 4ac, I'm going to go ahead. B squared is always going to be positive, because I'm squaring that negative, minus 4 times a times c. And I am going to, if you want to do it in your head, rock on, you can definitely do that. But I'll tell you what, I've made enough mistakes with getting tangled up in my signs that I want to make sure that I always get it right. So b squared minus 4ac, my discriminant is negative 4, which means that I have two imaginary solutions, no real solutions. All right, let's take a look at this one. My A is equal to 1, my B is equal to 14, and my C is equal to 49. Let's figure out what our discriminant is. B squared minus 4 times A times C. B squared is 196 minus 4 times 1 times 49. Go ahead and grab my calculator, and I'll say 196 minus 4 times 1 times 49. Check it out. Can you see that? The discriminant value is going to be 0. So when I go up here, I know that if my discriminant is equal to 0, that means that I have one real solution. All right, let's check out this last one. Oh, this is interesting. I have an A value of 7 and a C value of -3. I know that's my C because it's my constant, no x's. So where's my B? You got it. All right, B squared minus 4AC, 0 squared is 0, minus 4 times 7 times -3. 0 minus 4 times 7 times -3. Now these two negatives are going to end up canceling out. I'm going to get a value of 84. My discriminant value is 84. Now we'll go up and we'll see it's a positive number, which means I'm going to have two real solutions. But let's go ahead and take it one level deeper. Is 84 a perfect square? Guess what? It is not a perfect square, so I know that they are going to be irrational. And I know that if you're ever unsure, go ahead and try to take the square root of what value you get left. Now, the only reason why my digits stop is because my calculator is out of spaces. This is an irrational number, goes on forever and ever. You cannot take the square root of 84. You can simplify it, but you cannot take the square root of a number that's not a perfect square. All right, so here we go. We put it all together. State the discriminant, the number of nature of the solutions, then we solve. So we put it all together. You ready? All right, so we'll let A equal -1. We'll let B equal -2 and C equal to -3. My X is equal to the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. Let's go ahead and do that discriminant. Ready? 4 minus 4 times -1 times -3. Discriminant value of -8. Which, guess what? That means that I am going to have, because this is negative, that means I'm going to have two imaginary. So the number and nature of solutions, I'm going to have two imaginary. You might see them written as complex solutions. I have no real solutions. Hey, you know what that means? This graph doesn't ever cross the x-axis. This graph, and because this is negative, I know it's a reflection. That means that this graph, if I were to draw a sketch of it, this graph is sinking below. He doesn't ever touch the axis. But that's okay, we can still solve it. So x is equal to 2 plus or minus And remember my discriminant was -8 all over -2. So x is equal to 2 plus or minus. Let's break down -8. So when I take the square root of -8, that's the square root of 1 times the square root of 8. 8 is 4 and 2. Here's my perfect square. So I know that square root of 4 is 2. Square root of -1 is I. And then I can continue on my business. Square root of 2 over -2. Now this one's tricky because I have this negative here. So -2, when I divide out this common factor, divide by 2, divide by 2, divide by 2. Be careful here because 2 divided by 2 is 1. 1 plus or minus I root 2, and that's all over that -1. So the question is, what do I do with that? So you need to think about that -1 as being a coefficient outside that I need to distribute. So x is equal to -1. Now because I have plus or minus, it's not going to change the sign. I root 2. So this note here says imaginary answers always come in conjugate pairs. This is what we call a conjugate pair, this plus or minus the I. All right, let's do one more. Ready? Now, if you notice, I'm not in standard form here, so I'll rewrite it as 0 is equal to 2x squared. I'm going to subtract 3x from each side. And there I have my A and my B and my C. A is equal to 2, my B is equal to -3, and my C is equal to -8. So my x is equal to the opposite of B, plus or minus the square root of B squared minus 4 times A times C all over 2A. Let's go figure out what this discriminant is. So we have, there's my B squared minus 4 times A times C. B squared minus 4AC. And what do I get? A positive 73. So a positive 73 means I have a positive number. It's not a perfect square, which means my solutions are going to be irrational. So what I end up with here is I have 2 real solutions, and I know that they are going to be irrational numbers. All right, let's keep going. X is equal to positive 3 plus or minus that discriminant value that I got, 73, all over. And guess what? We're done. 73 doesn't break down. It's not divisible by 2, so it's not divisible by 4. And so if I wanted to play with 73, my only choice is a 3. I don't know, does 73 divide by 3? No. Does 73 divide by 7? No. Does 73 not by 3? That means not 6, not 9. It's not 2, so not 4, not 8, not 10. So I think I'm looking at a prime number here when we're looking at 73. So because I can't break that down and I have no common factors, guess what? My solutions, x is equal to 3 plus or minus the square root of 73 all over 4. So some people end up liking the quadratic formula because the exact answers sometimes cannot be simplified. Now, somebody asks you to estimate their answers. Let's say somebody says, estimate your answers to 2 decimal places. What I need to do is get my calculator back involved, because then this is what I type in. I'm going to type in 3 plus the square root of 73. And then I'm going to divide that by 4. And when I enter it this way into my calculator, I make sure that this is 1 in the numerator. So my first answer is x is equal to 3 plus the square root of 73, which is about 2, 8, 9 when I round. Then I'm going to do 3 minus the square root of 73. Divide that by 4. And then I have negative 1.39 when I round. So my estimated roots are here. And I want you to pay careful attention to how you type this in. If you had said 3 minus the square root of 73 divided by 4, this is not going to give you the right answer, because instead of dividing this whole quantity, so you're going to have to take advantage of using your parentheses and say 3 minus the square root of 73. Oops. We don't want that. Delete. And then close your parentheses there. Now divide by 4. Now you'll see I'll get that same answer there. So these parentheses become important because you want to make sure that you understand this is a wrong answer. This is your right answer. I avoid that because what I end up doing is pressing enter, and then I divide my answer by 4. So then that way, if I forget to use my parentheses, I don't get the wrong answer. All right, good job.